So you want to understand ball python genetics, but you don't have to memorize a bunch of names and numbers. In today's video, we're going to be going over everything you need to know in order to have a basic understanding of ball python genetics using recessive, dominant, and codominant morphs. Hey guys, my name is Benjamin, and I run this reptile channel you guys are currently watching on YouTube. And on this YouTube channel, we go over a bunch of different stuff, trying to give you guys the best possible care you can have for your pet reptiles. And specifically, we look at ball python care. So if you guys are very interested in that kind of content, please go down and click that big red subscribe button. It would mean the world to us. So for today's video, we're going to be going over the three main gene types, or types of genetics in ball pythons, which are recessive, dominant, and codominant genes. So the first gene type we're going to talk about is what people in the ball python industry call codominant. And here's a great example of a codominant morph. And this is one of the most popular codominant genes or morphs you're going to see on the market today, which is the pastel ball python. And the pastel ball python is called that because of these amazing yellows and golds you see going on along the back, as well as these amazing oranges, especially as babies, that you see going on the side. So what actually makes this a codominant morph? Well, to break it down in most simple terms, it means that if you take this animal right here, visual pastel, and you breed it to a normal ball python, on average, 50% of the babies are going to look like a pastel, and 50% of the babies are going to look like a normal. Now, while I don't actually have a baby normal to show you guys, I do have this adult male normal that's in shed right now. He's my big male called Zucchini, just to show you guys what normal looks like. So like I just said, the main thing that makes these guys codominant is if I breed this pastel to this male normal, I'm going to get on average 50% pastel and 50% normal. However, if I was to breed this pastel to this other pastel who is also in shed like that big normal we just saw, I would get on average 25% super pastel, 50% pastel, and 25% normal. So what does a super pastel mean? I'll put up a picture right now. And as you guys can see, the super pastel is basically just a lighter ball python compared to the normal pastel that has brighter colors. It's a little bit cleaner on the sides, has more blushing, and that head is very, very blushed out, which just basically means it has lots of white, sort of lighter colors in it compared to the rest of the body. And when we take that super pastel to anything else, every single baby must be at least a pastel. So for instance, let's say this is a super pastel, and I breed this super pastel to this male normal again, we're going to get, on average, 100% pastel babies. If you breed a super pastel to anything, every single baby must at least carry the gene for pastel. You cannot get a normal ball python in this pairing. Now the second gene type is going to be the dominant ball python, or the sort of dominant gene, or a dominant gene in ball pythons. And for example, we have a spider ball python. And like the codominant ball pythons, if you take this spider ball python to a normal, on average, 50% of the babies are going to come out like this, a spider, and 50% are going to come out normal. Now the big difference between the codominant and the dominant ball pythons is that with this, there is no super form. So if I breed a spider to a spider, you're never going to get a super spider, or you're never going to get an animal that is only going to be able to produce spiders if it's bred. So the two differences between dominant and codominant is that codominant has a super form, and while you'll get 50% of the offspring to carry the trait if you breed a dominant to a normal, a dominant ball python does not have a super form. Now the third type of gene, or the third sort of morph type in ball pythons, is going to be recessive. And recessive is lots of your more high-end stuff, like your albinos, clowns, and piebalds. And I'm going to show you guys this animal right here, and you're going to go, that's not a recessive, that's a lesser. And you are true. This has one other gene in it, which is lesser, which is a codominant gene. But recessive basically means, I'll basically explain it like this. Recessive is just like codominant, but it has a heterozygous form. So you might ask, what is a heterozygous form? A heterozygous form basically means that the snake looks like something, like whether it could be a normal or a pastel, but it's carrying an additional gene in its DNA code that isn't expressed. For example, if I was to take an albino ball python, we'll put the picture up right now. to a normal ball python, on average, I would get 100% of the babies to come out looking like they're normal. But in reality, all the babies are actually carrying the gene for albinism, or they're carrying the albino gene. So this female right here, as you can see, she looks like she's just a plain lesser, but inside of her genetic code, inside of her sort of DNA, she's also carrying the morph for clown, or the clown sort of gene. And I'll put up a picture right now to show you guys what a clown lesser ball python looks like. And as you can see, it is much different from just your traditional lesser het for clown. Now there is one thing that has to be noted with your sort of recessive genes. In order for the gene to be expressed, you have to have two of the same genes together. So like we talked about with the pastel, when you breed a pastel to a pastel, you're going to get a super pastel. It's kind of the same with recessive, but when you breed a het clown to a het clown, on average, you're going to get 25% not super het clown, but the visual clown, or whatever the recessive gene is. So, in order to actually have that gene be expressed, or in order to actually have that gene change the morph that it is in, or the snake that it's built into, it has to be a super form of the het, if that makes any sense. So, for instance, if I breed a normal clown to a het clown, on average, 50% of the babies are going to look like clowns, and the other 50% are going to be carrying the gene for het for clown. So hope you guys did enjoy this video. Hopefully this helps you guys out in understanding the genetics behind ball pythons. And I know that it can be very complicated trying to learn all the names and what the actual morph types mean. But overall, with some hard work and some dedication, it can be done. You can become a ball python genetic master like some of the bigger breeders that we do have today in today's industry. Can you guys do me a quick favor before we go? Can you guys go down and smash that like button? And of course, if you like the channel, consider subscribing. If you guys do have any comments, questions, concerns, or any sort of videos you'd like to see from our channel, please leave it down in the comment section below. I thank you guys very much for watching this video, and I will see you guys in the next video.